All right, part two, non-ferrous metals. These are metals that contain zero iron. One is magnesium. Another is copper. Okay. With magnesium, it has high strength to weight ratio, excellent machinability, and chips. The only bad thing about it is chips are highly flammable. Copper, obviously the oldest known metal. Okay. Kind of a brownish color to it. It's a good conductor, and you can shape it easily because it's fairly soft. Titanium, strongest metal out there. Strong as steel, but only half the weight, and highly resistant to heat. Okay. They use titanium plates on space shuttle, the heat shields and stuff like that. If you watch Apollo 13, they talk about that. If you watch Hidden Figures, titanium plating comes up. So that's where you would see the titanium being used. Nowadays you see it on golf clubs and stuff like that. Beryllium, used in nuclear applications. That's all you need to know about it. Okay. Pretty much the government controls beryllium like it's their business. Brass, identical properties to copper, but heavier in weight. Bronze, harder than brass. Both brass and bronze have basically the same color. One's just a little bit darker than the other. Zinc, zinc is resistant to corrosion, and it's usually used as a protective coating for steel, thus the term galvanizing. So if you buy something that has galvanized on it, you probably have something that's containing zinc. Tin. We will use tin in class here. That's also corrosion resistant. Pewter, you're looking at decorative stuff. Nickel, silver, same thing. Jewelry, stuff like that. Now, the one we haven't talked about is aluminum. Aluminum is probably the most common non-ferrous metal out there. It's universal usages. Okay. Some characteristics about it. It's soft. You can machine it easily. It does not rust. Okay? And there's a lot of it, really. I mean, all our projects, majority of them will be out of aluminum because it's easy to work with. Precious metals. Everybody knows what the three precious metals are: silver, gold, platinum. Our basis of our economy is based on these three items. Okay. The amount that we have of everything dictates our money situation. Now, high temperature metals. Columbium, used primarily in the aerospace industry, also used in nuclear reactors. Okay. Obviously, you need to keep this from faulting, so that's why it's a high temperature metal. Inside of a nuclear reactor, there's a lot of heat going on. Tantalum, this is used in rocket nozzles and heat exchangers in nuclear reactors. Once again, all these high temperature metals need to be stuck in, aerospace or the nuclear field. Nickel-based alloys, used in rocket engines, jet engines, and electric heat treating furnaces. Now, this is where you'd see it in real life. Okay. And then tungsten. This is used in welding and rocket engines. Now, tungsten's in both ferrous and high temperature metal, so make sure you're aware of that. Now, rare metals. Here are a few of them. Okay, there's others, but cerium, and I even got some pictures here for you, europium, and yttrium. Basically, yttrium. Now, I've looked all over for where these are used. We're looking at lasers, old televisions, picture tubes had pieces of rare metal in them. They're very good conductors. Okay. So, but basically, the government has control on pretty much all of this. Now, something new that's come out in the last few years are called honeycomb structures. Now, these structures are made up of sections of thin metal. These sections are bonded together to form a structure similar to a wax comb that bees use to store honey. And I've kind of given you an example down here. You got your thin sheet. You have your other thin sheet at the bottom, and inside you have what looks like a honeycomb. Now, the best possible thing that I've come up with, besides pulling apart a building and looking at it, if you work at a hardware store or a store like Tyson's, Lowe's, Home Depot, Menards, when they get batteries in on pallets, there are cardboard honeycomb sheets that look just like this. You can set a battery on top and it will not crush that piece of cardboard. So this stuff is very, very strong. Now, what are the shapes that metal come in? You have sheet, you have plate, which they're different, band, rod, square, flat, hexagon, octagon, angle, channel. The last one being I-beam. Now, in all of our classes and all of the class that we go through, we will use sheet, we will use band, rod, square, flat, angle. The rest of them you probably won't use, but I'm sure everybody's used a screwdriver in one time. That would be a hexagon piece of metal that you've used. It's formed into a screwdriver. Allen wrenches would be another place you would use it. I-beams probably won't. I've had one, but we cut it up. But you see them, they're used for in buildings. You know, NCI Cornerstone down here works on that. Channel, I do have a couple pieces of it, but we're not gonna use it in class. Angle iron, you're gonna use that when you're in the foundry. You get into advanced manufacturing too, you'd probably use it too. Okay, plate, probably not gonna use it. I do have some plate pieces in the storage room. The band, that you're using the bandsaw. All blades can be made out of that. Rod, square, you're using that in your tack hammer. Flat, you're going to use that on your thread gauge. So sheet, you're going to use for your dustpan. That's it. That's all the notes.